All right, so one of the big points in this lesson is that if you start with a function and you compute its derivative, you get another function. And so you could ask yourself, well, can I take the derivative of this function? Well, if it's a function and its graph is smooth, then it has tangent lines at its points as well, and so you can. And so we can take the derivative of the derivative, and we're going to denote that f double prime, and we're going to call this the second derivative. Okay, so the second derivative is denoted f double prime. And if we wanted to, we could also do this with the other notation. So we could do d dx. That's, say, taking the derivative of the derivative dy dx. And so the notation that we'll use is d squared y over dx squared. People don't tend to like this notation, but if you look here, it's pretty suggestive. Dx times dx is dx squared. D times d is dy squared. Those really have no meaning other than the 2. You're not actually multiplying in this case, but the 2 here is saying second derivative. All right, so we could take the third derivative and we could do f triple prime, or the fourth derivative, or the fifth derivative. The problem is, if you want to do the 10th derivative, it sort of gets a little bit hard to write, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then everybody else has to count those. It's not the best notation. And so in general, we're going to use the notation f not just to the n, not f to the n, but f to the n with a parenthesis to indicate the nth derivative. So here, this is the nth derivative. I will typically write the first, second, and third with the primes, but more than 3 primes, and we usually switch to the n notation. And so this would be, of course, the third derivative. Okay, so let's do an example we computed before, that if you start with f equals x squared, then f prime is 2x. I'll let you check that f double prime is 2 and f triple prime is 0. So the point there isn't how I'm computing those, although you should be able to take limits and do it. The point is that's the notation that we're going to use. Okay, just a quick application. We'll talk more about this a little bit later in the course. Whoop, I think I'm zoomed in too far here. There we go. If s of t gives the position of an object moving on a line. So, for example, our rock being chucked off of the cliff is going straight down on a line. That would be an example of this, or a car driving down the road, or various things. The point is, then the first derivative, s prime of t, is equal to the velocity of the object at time t. And we'll usually actually write this as v of t. So v of t, velocity, is the first derivative. And the second derivative, s double prime, which of course is v prime of t, the derivative of the velocity is the acceleration at time t. So that's pretty cool. You can see that second derivative having meaning. The function tells you where you are at a given time. The derivative tells you your velocity at that point in time, and the second derivative tells you your acceleration at that point in time.